This is my 11th standard on collisions. In this question it says, on the pool table there is two balls. The balls are at the same mass. The orange ball had an initial velocity of 4.0 meters per second in the positive x direction, and the blue ball was at rest. The orange ball collides with the blue ball and bounces off. The orange ball then goes off at 2.0 meters per second at 70-degree angle above the x-axis, and the blue ball went 20 degrees below the axis. Find the speed of the blue ball. So in this problem, it tells me that the ball bounces off each other, which tells me that is an elastic collision. And elastic collisions mean that the initial kinetic energy is equal to the final kinetic energy. I drew a picture of the orange ball going towards the blue ball, and then this is when the collision happens. The orange ball hits the blue ball, and then the orange ball goes up 7 degrees, and the blue ball goes down 20 degrees. And I have the initial kinetic energy equals to kinetic final. And I know that kinetic energy equals 1/2 mv squared. And then first I only have the orange ball moving, so focus. And then I have only the orange ball moving, so I only have kinetic energy of the orange ball equals to the kinetic energy of the orange ball after the collision and the kinetic energy of the blue ball after the collision. So I have Ke equals 1/2 mv squared, and I replace 1/2 mv squared for every Ke, and this is for orange ball initial, orange ball final, and blue ball final. And then since the masses are the same, I can cancel out the mass, and then they have the same 1/2 constant, so the 1/2 mass of in all of the variables go away. And then I'm left with v1 squared equals v2 squared plus v3 squared, and I need to solve for v3, which is the velocity of the blue ball after the collision. So to solve that, I subtract v2 to the other side, and I square rooted it. I plugged in my numbers. V1 was 4 meters per second, squared that, minus V2 was 2 meters per second, squared that, square root the whole thing, and it came out with the velocity that the blue ball was going is 3.46 meters per second. And that is how I found the speed of the blue ball after the collision.